The purpose of this project was to create a robot of our choice using the Hummingbird Duo and learn how to use the system on our own. A microcontroller is a compact microcomputer that is dedicated to one task and run one specific program. A script is where you input the commands on the computer to make the lights, sensors, and motions work that are connected to the microcontroller. A sensor is used to operate the lights, servos, or motors when that type of sensor is activated. When we first started this project, we decided what our idea was and we came up with an emoji. And then we made a sketch of what we wanted to look like. We decided on a circle, which was made out of foam board. So we cut that out, we cut the eyebrows and the lips out of cardboard, and then we carved the eyes that are styrofoam cones. And then, after all the physical things were cut out, we started to program. We used to program the eyes, which are lights. We programmed the center of the lips, which is a tricolor LED. We did the eyebrows that are servos. We did the rotary sensor that dims the lights, and we did the distance sensor that connected to the eyebrows. The last part of the script was when we made the microcontroller talk. And then when we were putting it all together and painted everything, we decided we should have a backdrop. So we made the backdrop out of poster board and we made it look like a text. So we had text bubbles, and then we had a contact that looked like someone was texting, and that was the last part of our robot.
Two examples of sensors that were in our projects were the distance sensor, which activates when something is a certain distance away or is close enough to activate the sensor. And we use this sensor to control the eyebrows that go up and down. Another sensor is the sound sensor, and it's activated when a specific decibel of sound goes off. Outputs are the resulted actions on the functions that were inputted into the scripts for the microcontroller. An example of an output in our emoji is the eyebrows going up and down, and also the eyes glowing. So a couple problems that we faced while putting together a robot was that our distance sensors, the ones that we were using, they were broken, and we didn't realize this until we finally we took out the distance sensor and put in a new one. We got a whole new microcontroller and used a new distance sensor, and when we figured out that it was actually the wires in the distance sensor, we got new ones. So another issue we had was that there were no more red LEDs left, so we had to only use the red and black wires on the tricolor LEDs, and that still worked fine, but that was another issue that we had. And we also had to switch to a new microcontroller since the one we were using before wasn't working properly. We enjoyed that we were able to figure out how to configure the microcontroller, how we want to work with it without much help from our teacher and from others. And we also enjoyed using our creative ability to build and paint the emoji the way we envisioned it. Overall, we really enjoyed doing this project because we were able to create our own robot that we first started out as a sketch and were able to build on our own. And we did face some struggles while putting together our project, but it did go pretty smoothly because we're both dedicated and problem solvers. For example, we had to figure out why the distance sensors weren't working out by trial and error, and it also helped us gain skills of an engineer that we did not have before working on this project. On a piece of paper, and it became into a project that that didn't make sense. An output are for the micro